Hello and welcome to this LoftZone practical guide on how to create a raised loft floor for storage or access purposes above the full depth of insulation in a loft. In the following modules, you'll be shown how to perform a full installation of the LoftZone product, leaving you confident and ready to install. At the end of each module, you'll be asked to answer a short series of questions in an online assessment to allow you to monitor your progress through this e-learning course. It is possible for you to rewatch any of the modules at any time if you feel it is necessary. We'll also detail frequently asked questions relating to LoftZone installations, as well as telling you where you can easily source your LoftZone products. So, let's begin. Module 1. Introduction. This video is a practical guide on how to create a raised loft floor for storage or access purposes above the full depth of insulation in a loft. It's well known that insulating a loft is usually the fastest and cheapest way to save energy. Laying insulation in an empty loft that is never used is easy. You can lay insulation between the joists, then over the joists at right angles, leaving the loft covering with at least 270 millimeters of insulation. The occupant is told not to use the loft. The job is completed and the insulation saves energy as it is designed to. But most people's lofts do not look like this. They instead look more like this. You've probably all seen a loft like this or know someone who has one that's full of stored possessions. But this causes a real problem. Firstly, because everything needs to be taken down from the loft before insulating. Secondly, many people refuse insulation altogether as they prefer to keep their storage. And thirdly, even if it is fully insulated, residents put things back up again after the insulation has been fitted, thereby squashing it. This problem is really common. The Carbon Trust interviewed 6,000 households in Britain and Ireland, and their research found that 82% of people use their loft for storage, with 78% saying it was more than half full and 76% saying the storage was very important or extremely important to them. Another similar issue is that people need safe access paths in the loft so they can get to equipment that needs to be maintained. All sorts of equipment need safe access pathways. For example, water tanks, boilers, solar inverters, mechanical ventilation systems, alarm systems, etc., etc. If you're installing the insulation for a landlord, they will often need to put in these pathways for health and safety reasons. So insulation in the area of the pathway is often squashed or left out by instead putting boards directly onto the joists. So why is this a problem? Well, squashing insulation with boxes or boards badly affects its performance. Research by the National Physical Laboratory, the UK's premier testing facility, showed that squashing insulation from 270mm down to joist height of 100mm halved its efficiency. Loft insulation partly works by being fluffy and trapping air, so squashing it stops it working properly. But in the Carbon Trust survey, most householders said they didn't know that squashing insulation was bad for it, and many people thought it actually improved performance. This is bad news for people who've insulated their loft, as they'll find their energy savings in the winter aren't as good as they expect. We know from the Energy Savings Trust that 25% of heat goes out through an uninsulated roof, and we've seen how squashing insulation halves its performance, and that 80% of households do exactly this. The summary is that unless you protect the insulation somehow after it's been fitted, you should assume that in most cases it won't work properly in practice. You have now reached the end of Module 1. Please complete the following assessment before continuing on to the next module. Module 2. The solution. The solution is to find a way to allow people to fully insulate their loft but still use it for storage or for safe access. Any solution has to be lightweight, easy to get into a loft, fast to install and strong enough to walk upon and store things on. There is one product that has been designed for all of these, the LoftZone Raised Loft Floor, also known as LoftZone Store Floor. The LoftZone Raised Loft Floor is the fastest, easiest way to install a safe raised loft floor. It consists of just 3 parts, all of which are made in the UK. There is a metal crossbeam which is very strong but also very light. It comes in lengths of 1.2, 1.8 and 2.4 metres. This is the 1.2 metre one and it weighs only just over 1 kilogram. There is a plastic tri-support which is also very strong as it's the main load bearing part, but it weighs under 300 grams and is 279 millimetres tall. And finally, there is a plastic uni-support which is also 279 millimetres tall. It stiffens the system up and weighs less than 100 grams. Here they are together with dimensions. We'll go into detail on how to assemble these in a minute, including how to screw the boards to them. But to start with, here is a short animation of how they all go together. You have now reached the end of Module 2. Please complete the following assessment before continuing on to the next module. Module 3. Installation Instructions. Preparation. Take all the safety precautions and safety equipment that you would use when working in a loft or insulating it. For example, using personal protective equipment, protecting downlighters, and making sure you don't step on the plasterboard ceiling as it may not take your weight. Make sure you've got access into the loft for all the parts you need. Remember, the smallest cross beams and the smallest boards are each 1.2 metres long. Don't install this product in a loft that suffers from condensation. The property owner should sort out the condensation first. Plan the size and shape of the raised floor before you start. It's not usual to build a deck over the entire area of the loft. You only need the space that's required for storage or for an access pathway. Usually this is placed near the loft hatch in the centre part of the loft where there is most head height. The deck can be square, rectangular, L or T-shaped, or there can be more than one deck in the same loft either side of the hatch. It's up to you and the customer. Try and keep the deck sizes to 1.2, 2.4, 3.6, 4.8 or 6 metres in each direction. These are standard sizes for boards. You can use other sizes, but then you'll have to cut the boards. LoftZone parts are available in kits for most standard size decks, but they also provide an easy configurator tool if you want to work out what you need for other sizes. If there are personal belongings or existing boarding in the loft, clear these out of the way. The LoftZone system is modular and can be built 1 square metre at a time, but it's more usual to move items to one half of the loft, then once it's completed to tackle the other half. When removing boards, be careful not to lift up the existing joists as this may cause the plasterboard ceiling below to crack. If the boards are in good shape, you may be able to reuse them later. Ideally, fit the LoftZone supports and cross beams after the first layer of insulation has been laid down between the joists, but before the top-up insulation has been laid over the top. Then put the boards on top of the deck last. However, if the raised loft floor goes in after the insulation, then you'll need to temporarily roll back the top-up insulation in the area of the deck. Before starting to build the raised loft floor, check for any obstructions, such as cables and pipes, and for uneven joists. The product is designed to allow you the chance to miss out joists or to bridge over obstructions, which is one of the reasons it's faster to install than any other system. So, plan where you're going to put your deck before you start. Also, check for the spacing between joists. In the vast majority of properties, they are 400mm or 600mm, which works fine with the 1.2 m and 2.4 m crossbeams, and the LoftZone product has a tolerance of up to 75mm. The one in this loft here is 600mm, which is fine. A small number of buildings have 450mm joist spacings, in which case use the 1.8 m crossbeams. If none of these are the case, you may have to cut the beams to size using tin snips or a saw. LoftZone works with wooden joists that are between 35mm and 50mm wide. The joists can be any depth, 75mm or 100mm are the two most usual options. The joists here are 40mm by 100mm, which is fine, but don't use LoftZone on steel trusses. It's also worth checking the ceiling before you start and notify any cracks to the occupant in case they later claim that you caused them. The only tools you'll need are a tape measure, an electric screwdriver and 4 by 40mm screws. You'll need 2 screws per LoftZone part plus extra for the boards. A laser measure is optional but will help when setting out. Setting out. Avoiding all the obstructions, place all the tri-supports in position before screwing them down. Use either a laser or a string line if there is a long row, or work off a fixed line like the truss webs or ceiling bracing if they are straight. It's easiest to set out the rows that the boards end on first and then the intermediate rows after that because their position is not so crucial. If you have an obstruction you're working around, then install the row closest to that first, then the rest of the deck can be built from there. There is a locating lip at the bottom of each tri-support. This also helps to provide lateral support for the deck. Try to alternate these lips so that one rests against one side of the joist, the next against the other side of the joist, etc. The rows of tri-supports should be 600mm apart if you're using boards that are 1.2 or 2.4 meters long, or 610mm apart if you're using 1.22 meter boards. Don't space them more than 610mm apart, as loft boards are not designed for greater spans than this. The critical rows are those at the end of the boards. Intermediate rows can have a bit of tolerance, but don't exceed the 610mm maximum. Make sure the tri-supports do not touch party walls or trusses. Leave a few millimetres gap instead. Leave at least 400mm gap near the eaves for ventilation. In some cases you may find that a row of tri-supports ends very close to a gable wall or other obstruction and the triangle doesn't quite fit. In this case, place a uni-support at the end of the row and place the tri-support on the next nearest joist. However, do not miss out the tri-support, as this is the main load-bearing part. Fixing. We'll now demonstrate how to fix the LoftZone raised loft floor using the 1.2 meter long cross beams. Start by screwing the plastic tri-supports to the joists. Each tri-support should be fixed with 2 screws into the joist it sits on. Use a low torque setting on the drill to minimise any chance of damaging the ceiling. Fix the tri-supports securely to the joist but back off when the screw is almost in. Do not screw in too hard or the tri-support can be damaged. The next step is to slide the cross beams over the tri-supports. They can be sharp at the edges, so we recommend wearing gloves. Slide all the cross beams in a row into position first before screwing any down, and make sure that each one lines up through a slit in the top of the cross beam with the hole in the tri-support below. At this time, fit but do not yet screw the uni-supports into place by placing them into the cross beam and rotating them into the locked position on the joist. The uni-supports stiffen the deck up and help to transfer loads onto joists that are otherwise spanned over. We recommend 1 uni-support on every second crossbeam, and you should place them evenly underneath the deck or in the areas where footfall is highest. Make sure the hole in the top of the uni-support is located underneath a slit in the crossbeam above it. In the unusual case where the slit does not line up, just drill through the steel crossbeam. Once all the supports are in position, screw each crossbeam down firmly anywhere through the slit on the beam into the pre-drilled hole and the tri-support below. Note that it's normal for the crossbeam to be compressed down slightly into the tri-support. Then do the same with the uni-supports, screwing them into the crossbeam with a single screw and screwing them into the joist. There are 2 screw holes at the base of each uni support for ease of access, but you need use only one, unless it's at the very end of a row. Now is the time to roll out the top-up installation in the loft. However, do not sit or stand on the supports nor beams until the boards are screwed down. The next step is to fix the boards on top of the cross beams. Place the boards in position over the top of the beams, allowing for their tongue and groove fitting. You can use small loft boards, 1220 by 320 or 325mm, or larger ones, 2400 by 600mm. The board should be at least 18mm thick. Where the boards end in the middle of the deck, the boards should reach halfway across the 80mm width of the crossbeam. This is to allow the next board to be supported by the same beam. Where the boards finish at the end of the deck, however, you can take these right up to the edge of the crossbeam or even allow for a short overhang. When in position, screw the loft boards directly into the metal crossbeams. Use 3 screws per board and 6 screws for end boards. You must screw through the board into every crossbeam. Do not miss out the middle beam. Don't try to fix the screws into the slits in the top of the crossbeams, but instead just screw them directly into the metal itself, where they will self-tap. Do not screw into the tri-support, only screw into the metal between the supports. Use an appropriate torque setting, bearing in mind that there is a plasterboard ceiling underneath, which you don't want to crack. If the screw pushes the board up, back it off and start again. Usually there is no need to pre-drill pilot holes in the boards, nor to countersink them. Finally, remove all your tools from the loft and affix the loading warning sign somewhere prominent that is close to the loft so that it can be seen by people entering the loft space. LoftZone provides a warning sign in the installation booklet that is included with the parts, or your organisation may have its own. Note, if you're using longer cross beams, i.e. 1.8 metre or 2.4 metre long, then still follow all the previous steps except that you only need 1 tri-support at the end of each row. Use 2 uni supports in between the tri-supports underneath the cross beam. You'll find that using longer beams makes the installation much faster, but make sure that you can get the longer beams into the loft first. You have now reached the end of Module 3. Please complete the following assessment before continuing on to the next module. Module 4. Important information. The LoftZone raised loft floor is very strong. It has been tested to withstand several hundred kilograms per square metre without failure. However, it's only as strong as the joists it is screwed onto. It is not a substitute for a loft conversion and should only be used for storage and occasional access. The warning sign provides guidance as to the maximum recommended loading. The LoftZone raised loft floor can be used with insulation of up to 350mm deep. As described earlier, this product should only be fitted in well-ventilated lofts that are free from condensation. However, it's known that boarding a loft can cause a risk of condensation all by itself, where the moisture forms on the underside of the boards, causing damp. This is known as interstitial condensation. The LoftZone tri-supports and uni supports are 279mm tall precisely to counter this risk by allowing for an air gap between the underside of the boards and the top of the insulation so that air can flow between and remove any moisture. This is also why there are holes in the cross beams. Make sure that when you install the insulation you leave this air gap in place and that there is a clear path for the air to travel from eave to eave. The LoftZone raised loft floor has been tested and shown that it does not cause a significant thermal bridge in the loft, i.e. it does not transmit heat through the installation. It therefore does not affect the SAP or EPC calculations for the property. Why is the LoftZone raised loft floor so fast to install? Many lofts can actually be quite difficult to work in. Getting long or heavy items into the loft can be difficult. Joists can be uneven, or they can have varied spacing between them, and there can be lots of obstructions in the way, such as pipes, wiring, or trusses. This means that whilst many other means of installing a raised floor in a loft may seem easy, they are not in practice. LoftZone has, however, been designed with all these in mind. The cross beams span over joists, so if you have any that are uneven or carry surfaces, you can simply miss them out. The design of the cross beams going over the top of the tri-supports means that the system can cope with uneven joist spacing because the beams slide over the supports. Previously, if you were boarding directly onto the joists or using rigid insulation, you'd have to cut the boards or insulation to size, which is awkward and time-consuming in a loft. And if you're using a raised deck system that has just vertical supports, you may find that the boards simply don't reach all the way, which can be a safety issue. The small number of parts means fewer screws. If you were to use a system that only has vertical supports, you'd have to put in as many as 6 times more screws. The LoftZone parts are much lighter than using timber to raise up the raised loft floor. This is important as the more weight you use in the flooring structure, the less weight can be applied to the floor, therefore reducing its use as a storage or safe access platform. Timber also acts as a thermal bridge, i.e. allows heat to escape through the insulation. If you use timber to create your raised platform, in some circumstances you're now required under building regulations to recalculate the SAP score for the building because of the reduced heat loss. The good news is that the LoftZone parts are plastic and do not cause thermal bridging. An important consideration is avoiding the risk of condensation on the underside of the boards. The LoftZone system has an air gap between the insulation and the boards to allow any moist air to be carried away. Even if you use any other construction method, e.g. rigid insulation or timber, you would need to build the platform up well above the insulation with a sufficient air gap to allow the air to be ventilated. Polystyrene insulated boards should not be used near where there are electric cables, as the chemicals in the polystyrene cause the cables to become brittle over time, which can be a fire hazard. The LoftZone parts don't contain any polystyrene, and even if the insulated boards don't contain polystyrene, they still can't be fitted easily when you have uneven joists, obstructions such as surfaces, or uneven joist spacings. So they can often take much longer or look uneven, and they are usually more expensive than LoftZone for the same insulation value. Finally, insulated boards don't leave an air gap between the insulation and the board. According to the Buildings Research Institute, an air gap would help to reduce condensation. You have now reached the end of Module 4. Please complete the following assessment before continuing on to the Frequently Asked Questions video. Frequently asked questions. What about loft ladders? It's easy to incorporate a loft ladder. Here are 3 options. You can use a concertina style ladder that stows inside the hatch. You can use a normal ladder that would normally be hinged onto a joist in the loft and stow in the loft, and instead hinge it onto the side of the deck directly above a crossbeam, or build a timber structure below to support the load. Or you can fix the ladder to a joist as normal and then stow it in the area away from the raised floor. What about trimming around obstructions? In most cases, it is easier and much faster to build a smaller deck that avoids all obstructions and means that no beams nor boards need to be cut. However, if the customer wants a bigger deck, it's possible to trim or slot and notch around hatches, chimneys, tanks and truss webs. But this does take longer and requires basic carpentry skills. If you need to trim around a hatch, then put in an intermediate crossbeam if necessary and use uni supports at the end of the other beams. What if I'm boarding the whole loft and the last crossbeam of each run does not have enough space to slide on? Most people don't board right up to the edge. However, if you do wish to do this, then you can slide the final set of supports under the crossbeam and then position the crossbeam in place before screwing everything together at the same time. Do you have a technical support line? Yes, you can call LoftZone on 01483 600 304. Can I become a LoftZone fitter? Yes, we have a series of approved installers who undertake local marketing and installation in their area. Contact LoftZone if you'd like to apply. Where to buy? LoftZone sells both standard size kits and individual parts. LoftZone can be bought from many builders merchants online at www.loftzone.co.uk or by phone on 01483 600 304. Call LoftZone for trade prices. You have now reached the end of your online LoftZone installation practical guide. We hope you've enjoyed this online learning experience and are now fully confident in installing our product. Now you have completed this online course, you'll be sent a digital copy of your certificate within a couple of days. If you have any further questions or queries about accreditation or installation, please call LoftZone on 01483 600 304. As stated previously, you can rewatch this course or specific modules as you see fit. Thank you for choosing this LoftZone online training course. Goodbye.